Hey everyone, and welcome to my talk about GraphQL Federation. I'm Derek, and I work at Apollo, and well, let's talk about GraphQL and APIs. So, as I mentioned, I work at Apollo, right? So, Apollo is the leader in the GraphQL space. We maintain a number of open source available, and SaaS offerings that help you build, maintain, and scale your graph. Myself, I work on all things federation, which includes the composition phase, the query planning, and a number of tooling and libraries around that help you basically use federation, right? And if you're building GraphQL APIs or thinking about building GraphQL APIs, definitely check out Apollo. But let's talk about APIs, right? And specifically, I want to talk about this layer in between your customer-facing applications, the clients that basically that user interact with, they click through, they buy stuff, whatever, right? And your domain services, your business logic, your APIs, that where all your business logic lives, right? And this is the layer where you do all your aggregation, right? You gotta call different endpoints, you gotta do integration of those different sources, orchestration, augmentation of data, enrichment of data, transformation of data, basically all in between, right? And I personally like to call it, well, experiences API, because, well, they power your experiences, right, that user interact with. So what are the couple different strategies how we can actually manage it, right? So first of all, strategy number one, well, there's no layer at all. And we have our clients, they call directly your services, APIs, and it works, right? Very simple. And it works until 2 days later someone comes in and say, well, we need more data. We need to change something there, we need to fetch more data. So you keep adding additional calls there, right? Maybe you need some orchestration. I call this API first, I take this data, I call another one, and so forth and so forth. And this pattern, right? Also, it's as you mature with your, the API platform, you're gonna get more and more APIs, more and more clients, and basically it's just gonna grow and grow and grow. And don't get me wrong, this actually works. This is how we've been building our applications for the last 20 plus years, right? This is how we've been always doing that, but is there a better way to do that, right? So, if you're looking at this approach, right, all of that orchestration logic has to reside within the clients. They have to know, I have to call my product's endpoint, then using the product, I'm gonna get my reviews data, using the product, I can calculate the price, I can do all that stuff, right? So I do all the orchestration in the client. But you're probably gonna have multiple clients, right? So you start with the web, then you look at your the native apps, so Android, iOS, maybe you're gonna do some watch thing, whatever, right? And they all probably wanna have similar experiences on them, right? So you're gonna try to call the same services. But the reality is, they have different requirements, right? So if you're on a desktop, you got a big monitor, you got a big pipe connected to the internet, right? You can fetch a lot of data. You can display a lot of data to the users, right? If you're on a mobile, on some 3G network somewhere, probably you don't want to spend that much time fetching the data that you're going to just throw away because you're not going to show it to the user, right? You want to prioritize what you want to get. And so what happens in this situation, right? Well, you can have a single API for those two use cases, but then you end up overfetching or underfetching, right? So you create another endpoint. So instead of a single one, you have your desktop API, you got your mobile API, and so forth and so forth. Maybe there's a V2 endpoint that adds more data as you go through, right? So this just grows and grows and grows, right? So around 2015, folks at SoundCloud, they came up with this idea, right? That what if this orchestration logic that's within the app, right? Why don't we move it outside? Why don't we keep our application simple, right? I just want to call something, and I want to get the data that I can just use. I can just, do that stuff. And this orchestration layer is just going to call all the stuff underneath, behind it, right? All orchestration, aggregation, all that stuff is going to do that, right? So, and they called it the backend for frontend, right? The BFFs. Now we have the BFF. It sounds great, right? It's a good idea. But since then, something happened. We all shifted towards the micro frontends. So instead of having a couple different, API, like applications, right? Now you have dozens, 50, 100 more, right? So like think about it like if you are an e-commerce, right? Selling, travel, because I used to work at a company that does that, right? So you have a different UI and different micro frontend for your selling flights, selling hotels, selling car rentals. All of those are separate ones, right? And in this approach, well, it's BFF for everyone. You get one, you get one, you get one. Everyone, I get one, right? And in this approach, well, spinning up a new BFF, again, it's a lot of them, they overlap with similar logic because you want to have similar experiences, right? So you copy it over, spin it up, fine, right? But managing all those BFFs comes at a cost, right? And what's good about it is that you still have the insulation from the client to your services, right? So the clients want to, they want to evolve, right? You want to change to the next JavaScript framework of the week. You want to do some other stuff there. On your backend, maybe you want to switch your databases. Maybe you want to update your APIs to the new stack, whatever, right? So you get this insulation. So yes, there's a coupling between the client and the BFF, but you can change the stuff underneath the BFF without affecting the client. Right? And again, there's this tension between the client needs and the backend needs, right? So everyone has their own backlogs, priorities, what they want to do, right? So clients want to iterate fast. They want to experiment with things. They want to build different things, right? And the backends, well, I want to give you the best APIs out there, right? I have my own backlog with the features that I want to ship, right? I don't want to manage 100 different API endpoints for you. You're all different use cases. Especially if you ship mobile clients, like native clients, once you ship something to the App Store, well, you're kind of stuck. People don't update those apps very, very often, right? So you may have to keep that API for 6 months, a year and a half. So that's an additional cost that the teams have to manage. So that's from all of those issues, right? Folks came up with the GraphQL, right? So originally at Facebook, they open sourced it. It's already, well, they open sourced in 2015, so it's already been around for a while, right? So the strategy number 3 is GraphQL federation. And you see a little asterisk over there. It's simple because the GraphQL federation is an ongoing effort by the working group under GraphQL Foundation to basically standardize how we federate the data, how we do federation. It's still very early stages on it, but since it's heavily based on Apollo Federation, the original implementation of federation, it takes all the same principles. It basically simplifies some things, but it's fully backwards compatible. In my talk, I'm going to be using interchangeably, so GraphQL Federation, like it's Apollo Federation. So before we talk about GraphQL Federation, right? Let's take a step back and say, what is GraphQL? Right? So if you look at their website, it says query language for your APIs. Awesome. What does it mean? All right, you read through it, and it's like, oh, okay, there's a spec, there's multiple implementations, and what it allows you to do is you expose the data in a certain way that the clients can selectively ask for what they want and just get that. Oh, okay, sounds good. And still, can you make it simpler? At the end of the day, GraphQL is technically just a post with a body that specifies the shape of the request and the response that they expect, right? So clients write the queries, and they get the data that matches exactly the shape of the data there, right? So compared to like REST APIs, right? So we have multiple different endpoints. They return you the complete entity data, whatever is defined for the endpoint, right? Here we get single GraphQL endpoint, and users write those queries, right? They write those queries based on a schema. So schema tells you all available data that you can see, that you can query, that you can get, right? So may sound familiar. There's open API spec, Swagger on the REST side of things, right? But there's a big difference there. So with GraphQL, the schema plays a central role. It's actually used by a runtime to make those guarantees for you. So it's strongly typed. Everything there has to have a type. So every field that you're fetching there has to specify what type it is. So whether it's something simple like some primitive values, strings, integers, right? Or some more complex objects. Everything has to have a type. And furthermore, when you define those types, you also have to specify their nullability. So if you say something is not null, you're guaranteed to get it as not null. So if I'm getting my name here as a string that's not null, I'm always going to get it. This allows clients to generate the code that basically is type safe. They know, like, if I'm getting something that's not null, I don't have to handle the nulls because they're never going to be null. You don't have to guess it, right? So this brings us to the GraphQL federation. And it's, in simple terms, it's basically how you combine multiple GraphQL APIs in a single one, right? So having a single GraphQL API, that's great, but if we're living in the microservices world, you're probably going to have a number of different GraphQL servers, right? So how do you combine them together into a single one? So GraphQL federation allows you to build your distributed GraphQL APIs in a declarative manner. Right, so all of these are perfectly fine GraphQL servers. They are fine to run by themselves, but we can combine them into a single one. And the one thing that comes to mind is like, okay, so sticking a gateway in front of the APIs, it makes sense, right? That's what we do, right? But with the other APIs, we have different endpoints. Here, everything is GraphQL. So hey, so what do I do then? Well, the answer is, well, we have a schema, right? We have to merge the schema. And the process of merging that's what's called composition. So during the composition process, we're looking at all the types, whether they're consistent across different subgraphs, whether they can be merged, and such, right? And as an end result, we get this super graph that the clients can interact with it. And it looks like it's a one API schema that they can interact with. They don't know that there's like a dozen or so services underneath it. It's just one API call for them. Which brings me to another big concept of a federation. It's the concept of entities. So in simple terms, entities are objects that can be uniquely identified across the graph. So thinking about like database terms, you have some rows with some unique keys. And I'm talking about unique keys because then it can be multiple ones. You can have a single field, maybe it's a collection of fields, maybe it's some complex objects there. You can do a lot of those different ways of how you identify those objects. But once you identify them as those entities, one of the principles of federation is that given this ID, I can resolve this type everywhere that actually knows about it, and it's going to point to the same thing for me, right? So this leads to some interesting features. So first of all, right? So I have my product subgraph, right? I define a type product there, and I have a key there, so it's an entity. And if we're looking at traditional, like REST-based APIs, we would have something like products / ID, right? If I want to add reviews to it, you would have product, ID, reviews, right? Maybe that's a different endpoint. But maybe you're cheating because you don't want to make those extra calls. Maybe you're going to have products with reviews for you, right? That's another endpoint to do that. But maybe fetching this product's data is also somewhat expensive. So maybe you're just putting some stubs there. Maybe you don't have the whole information about product there. Maybe just putting like some maybe description or something like that you need to display there, right? With the federation approach, well, the teams can extend those entities across different graph boundaries. So you may have a product subgraph owned by your product team. They know everything to do about the product. That's like there's a whole bunch of data there behind it, right? And maybe you have a reviews team that knows everything that there is to do about reviews. And you will say, I know that there's a product somewhere over there. I know there's a type there. And I know how to identify it by this ID. And what I can do is I can add additional feature to this. I can add a reviews to it. And the end result is that the users looking at this graph, they see I have a product with reviews. It's a very powerful concept, and you can, once you keep adding those new functionalities to the graph, you're basically magnifying your investment as you go, because you're getting more features and capabilities built in. But just adding new features there, it's fine. But sometimes you also need to reference the data from the other graphs, right? And you don't want to just repeat it over and over and over again. So there's concepts there that allows you to say, I have dimensions of my product, right? There's like some the width and height and weight, and I do have a shipping subgraph that's going to calculate me the cost of it. So I can say, well, if I'm calculating this cost, if someone calls this, I need this additional data from another graph. And from the user perspective, it's actually transparent. You see, there's a product, and I have shipping costs with the zip code. All that other stuff is handled behind the scenes, right? So this brings a good question now. It's like, okay, so we merge this graph together, right? And we have a schema that looks like it's one thing, but in the end, it actually, based on the query, it can go to all those different places, right? So how does it actually work? And this is why we have this thing called Query Planner. So the router is a smart router that actually can understand your queries, is going to figure out the best way across your supergraph how to fetch this data. And it's going to generate you nice plan as well that you can actually take a look and see what happens there. So from a user perspective, they just get a product with reviews and shipping costs, right? It looks like it's one thing. That's what you would expect, right, when you're hitting like the REST API. Here is actually, we're gonna fetch the products from one graph, and then we're gonna, in parallel, we're gonna call the reviews and shipping. Because, well, we can do that at parallel. We don't have to wait for one for another, right? And at the end, we just flatten it all out into the result and return it to the user. And it's super powerful concept. It's once your graph grows, the complexity of those plans grows as well. And the algorithms there, well, let's say it this way. I thought it was much simpler because I spent last year rewriting that in Rust. And before that, I thought like all those interview questions about the graph theory with the GraphQL structures and like graph structures and all this stuff, that was kind of the interview question. This actually uses a lot of that. All the computer science stuff that think of, it's pretty complex piece over there. But because we have this functionality, we also can add more advanced functionalities there as well. So using GraphQL features that's still being developed, there's this concept of defer, right? So if you're working with applications, well, the time to first byte, time to first user interaction, it's crucial, right? You want to get your stuff out the door as fast as possible so users can interact with it, because the longer they wait, more likely they're going to abandon the stuff, right? So using defer, we can say, well, I know that I need to get my, the shipping information, how much it's going to cost. I need my product information. I need to show you as fast as possible. So I need this information. But reviews, well, maybe it's slow. Maybe, I don't know, sometimes it's slow, maybe it's not. I can say, I can wait for it. And the Query Planner is actually smart enough to actually do those things for you. And if you're using the clients that understand defer, it's basically you're going to get data here on the left first, and after a while, the other parts when it's ready, back to the user. So you can start drawing and interacting with the user as faster than before. So there's a lot more features there and federation that specifically, I guess, about Apollo Federation that you can actually get out of as well, right? So there's, you can have, since we can uniquely identify those entities, we can also do caching around them, right? Each client can specify their own queries, right? So caching the whole response of those queries may not be that great because they're all might look slightly different, right? But if we know that this is the concept of entity, I can just cache the pieces there that are actually relevant to me and actually speed up the delivery, right? If you're using polymorphism in GraphQL, you can have some common interfaces for your entities, right? And instead of adding this field, a new field everywhere in your, individually, what you can do is you can use interface object to add it in one place, and all of your implementation of this entity is going to get it. There's a built-in demand control that you can have field level authorization there for you. So if users attempting to read something, they need to be authenticated, they need some scopes or policies. You can pass the JWT tokens, and router is going to handle that for you. When we're building the graph, there's possibility that you want to move stuff around as well. So the progressive overrides allow you to move pieces of the graph to another, shift the traffic incrementally. That you can do that migration very safely. And the last part I want to highlight here is also like when you're fetching the data, like within a single graph or a single service, accessing your grandparents' data or great-grandparents' data, it's still same service. You can probably propagate it out. In a distributed system, that's not an easy thing to do, and there's no mechanism in GraphQL to do that, per se. So using our context, you can say, well, when I'm resolving this first piece of the query, I'm going to save it. And then down the road, when I actually need it, I can reference it, and the query planner is actually going to pipe it out and send it out downstream, right? There's actually more features there that, there's a lot of different use cases that Federation dives in. But with all this, right, you might be wondering, so why GraphQL, right? I already have my apps, I'm already happy with my stuff, right? So why would I even bother looking at GraphQL, right, in GraphQL Federation? And, the thing that pops out often is like, okay, so GraphQL versus REST, yeah, which is better, we're going to replace everything with one technology, not one size fits all, one size rules all. But this is a bad question. This is not the question that you should be asking about. It's actually, GraphQL is not there to replace your APIs. GraphQL is just to make them better. So a common pattern is putting the GraphQL in front of your existing APIs. And there's lots of benefits for both the front end and the back end folks that you can actually benefit from using that. So the front end folks love it because, well, everything is strongly typed. I have my types, I have my schema, I'm guaranteed to get it, right? There's no underfetching, overfetching. I get what I want, right? It's awesome. There's faster application delivery because, well, if you have your schema, you don't have to wait for those different custom endpoints for you to experiment with it. You can just update your query and, call it a day. It just works, right? And you get stuff for free, like, defer. There's stuff that, you don't have to wait for it. You can just get, right? But what about the backend teams, right? And it's like, I like my REST. I like my APIs. It's already there, right? Why would I even bother looking at it, right? If you remember, at the beginning, I was talking about the concept of BFFs, right? That you have this custom tailored API for your clients, right? With the GraphQL, it's not necessarily true, but I kind of like to think about it as BFF for everyone. So instead of writing all those different BFFs, you just write it once. So the clients use what they want. So you don't need to maintain hundreds of different API variations on it. You can just have a single API that provides those capabilities for you. And I think what's great Well, GraphQL, that also gives you observability on the API usage directly. So with traditional APIs, right, you hit an endpoint, you get a data back. Okay, so I know someone is calling me and using this data, right? What happens next? I don't care. It's your responsibility. With GraphQL, we know what clients send us. We have queries. We know who's using what, which means, well, I can easily evolve my schemas. Adding new features, no problem, no problem. No one's using it. I'm not gonna break anyone. I can ship new stuff without waiting for anyone. I can ship it, it's there. People can start adopting as soon as possible. Removing stuff, well, I know if anyone's using it. If no one's using it, I can just drop it. No one's using it, no, fine. You can just drop it, right? What if someone is using it, right? So you can actually communicate to your clients that, hey, this is getting deprecated. So instead of sending emails, you can actually put it into your schema, say, well, this is getting deprecated, right? And next time they're actually building their client applications, they will have a warning saying, hey, you're using deprecated API, make sure to update, right? You can actually configure those client generation libraries to actually error on the build time. So you never ship a code that is using any deprecated APIs. And remember, as I said, once you ship to App Store, it takes forever to migrate on it. So you're still gonna have to maintain those for a while, but you're gonna be there, right? But accidents happen, right? Well, what if I'm just refactoring my code and I changed some of the fields there, right? And I was like, just fixing a typo or something, right? Using GraphQL, you actually, if you tie it into something called like schema registry, you can detect those breaking changes before you deploy. So it's gonna find out that, yeah, you're changing the schema and those are the affected clients, so don't ship it. Or maybe you do, I don't know. So a lot of features there for free. And last but not least, well, you don't have to maintain any of that orchestration before, right? You can, sure, if you want. You can put that logic inside of a code, but Query Planner takes care of the calling all the downstream. All what you're gonna be doing is, I'm fetching this data from there, I'm fetching it from there, and I'm combining it together, well, Query Planning takes care of that for you, so you don't have to maintain that code either, right? So in my opinion, it also makes a compelling case for the backends. But, maybe you're still not sold, right? You're happy with your existing experiences, your existing apps, and whatnot, right? So, but what about the new experiences, right? Right now, the big thing that everyone's talking about, well, is the AI, large language models, right? Everyone is doing the chatbot or the agents, and everyone's looking for it, right? So how are you gonna support it with your existing APIs? Well, if you wanna connect it direct, well, it does work for a handful of APIs, right? If you have a single API or two, sure, but what if you have this orchestration that has to happen, right? Are you gonna create a BFF for it? You're gonna create the BFF for those 100 different chatbots that you might be working on? Well, it's up to you. It's the LLMs by themselves are not smart enough to figure out this orchestration, right? So I call my products. I get this to get the reviews. From the reviews, I get those users that actually did that. LLMs are not smart enough to actually dedicate that. And you can actually try it out. Say, ask your favorite, the Copilot tool. Say, hey, generate me BFF that does X, Y, Z. And it's going to give you something. It's going to be mostly correct. But mostly it's pretty much useless, right? So we already have this orchestration there, right? So instead, why don't we just point it at the graph, right? And the LLMs were created in the environment that GraphQL already existed. They already know that the GraphQL exists. They know how to interact with it. And it's actually, they do pretty well with it. And since you're handling all this orchestration logic there, it actually makes much, much easier integration for you. And there's actually a very nice pattern that we found that actually works pretty well, right? So if you use traditional like RAG database, that's static data. You cannot update it, right? And this, in enterprise, you get hundreds of APIs, hundreds of developers, they're working on it, they change the APIs, it constantly evolves, right? You cannot have static data. So using this approach, right, what we do is we vectorize the supergraph, so LLM can understand it. Whenever there's a change to it, we just pipe in the delta there, right? And we probably don't want to let those LLMs run loose on your APIs. You don't want to let them free for all, do whatever the hell they want, right? You probably want to restrict them so they obey and do the right thing. So what you can do is you can write some set of operations that are safe for them to use, and those are the ones that those are the only ones that they can use. So you provide a list of safe listed operations, and again, you inject that into the vector database. And what happens next is that your customer raise a question, right? And LLMs are great at parsing the questions from the user. It's like parsing language, they're great at it, right? So they do a similarity search then against your vector database, find out, okay, this is the data that you're probably looking for, right? Those are the queries that kind of like look like probably the best approach there, right? And they're gonna build you a query for it called the GraphQL federation, the router there, and it's gonna get you the response back. That's gonna be matching the data exactly as you want it, right? So maybe now you're sold, right? Yeah, everyone want to get a GraphQL federation is the way to go, right? So now the question is, how do you do it, right? So the reality is you're not starting from scratch. You probably have years and years of buildup of those APIs, and as I said, you're not gonna throw them away, right? And this is not to replace your APIs. This is basically to make them better, right? To enhance it, right? So one of the common ways of doing that is, well, you build a GraphQL server, right? You stick it in front of your API or multiple APIs, and it works, right? You had great control of it. You define the schema. You get all the logic there, resolvers. You control everything there, right? And federation is GraphQL Apollo Federation is supported by tons of different frameworks, like 30 plus frameworks, pretty much all the major languages. So if you like Spring and Java, sure, there's a couple options. There's tons of JavaScript, .NET, Python, all this stuff is there. But you can pick and choose whatever matches your stack. But there is a pretty high cost with it, right? So as I said, you get the most control, but if you have hundreds of APIs that you want to migrate to in this model, it's going to probably take a while to get there, right? So hot off the press, about 2 weeks ago, Apollo had our own conference that they announced the Apollo connectors. And this allows you to programmatically add your REST APIs to the GraphQL federation without writing any code. So you define your schema, sure. So you still get your, you define the schema, that's the artifact that you want to use, and then you connect it to your existing REST sources. You point it at it, you still use the authorization, all this stuff, it all works, right? And what you have to do next is basically provide a mapping, how you want to map this JSON response that's coming from, from the server to your GraphQL data structure. And there's actually a great VS Code extension that helps you manage all that stuff. There's a language like a server that just does the highlighting, shows you all the errors. It's pretty fun demo. Sorry, don't have it over here. But it's pretty amazing, right? So to wrap this up, right? And looks like I'm going to be pretty fast, but to wrap this up, I want to leave you with a couple thoughts, right? So first of all, AIs, they're going to need APIs, right? All your, you have to get the data from somewhere, so they have to call something, right? You need to be able to provide this data somehow, right? The second thing I want to leave you with is, well, GraphQL makes your APIs better. It's not a replacement for your stack. It's not a replacement for your APIs. It just makes them better, provides you those extra capabilities for you for free. Well, not for free, but provides you those extra capabilities that you can utilize and use right away. And last but not least, tomorrow's experiences, they're going to be built on existing APIs, right? And more specifically, tomorrow's AI experiences will be built on the GraphQL Federation. So, thank you.